All right, question number 3. It's on based on objects that are in equilibrium, right? What do you mean by equilibrium? The net force will be zero, right? So it says here equilibrium, so net force is zero. The objective is calculate unknown forces for objects that are in static or dynamic equilibrium. Here, the object isn't moving, so it is in static equilibrium. All right, let's look into the question. It says a 33 Newton force acts at 90 degrees from the x-axis and a 44 Newton force acts at 60 degrees from the x-axis. And both angles are measured counterclockwise from the positive x-axis. What are the magnitude and direction of the third force? Okay, so here object is in equilibrium, so we know that there will not be any net force. So let's see how to first sketch the diagram. So we all know the x-axis is the horizontal axis, so you have it this way. Now let's draw the forces. Now 44 Newton is at 90 degrees and it says counterclockwise means you go this way, right, to the left. Clockwise is the other way. So if I take one of the forces to be from this at 90 degrees, so you have that 44 newtons here, which is at 90 degrees from the x-axis, right? That's the first force. Then the second force is at 60 degrees from, again, the x-axis. You are measuring it counterclockwise, so which is also between this 90 and this, somewhere, say roughly about here, right? So this is the second force. So this 44 Newton is at 90 degrees here, and the second force, oh sorry, the values are wrong. This is 33, my bad. This is 33 and this force is 44. Okay, a 33 Newton force acts at 90. All right. Now, how do we find the third force? So we all know that when the net force is zero, it should form a closed triangle. So we need to find the third side of the triangle. So first let's calculate the magnitude. So the magnitude here, if it is such situation, which rule do we use? Cosine rule. So I wish to draw the diagram by head to tail method. So the first vector or the force is 33 newtons here. The second vector is 60 degrees. So this angle is 60 degrees and that's 44 newton. And we need to find the third vector's magnitude by using this, right? Okay. So what is the total angle? We know that this angle is 60 degrees, but we need to know the full complete angle from this point to this point. So we will add, this is 90 degrees. So 90 plus 60 will give you 150 degrees. So as I have always been telling you, first the sketch of the diagram, the situation, and then apply the formula. Usually the cosine rule will be handy to find the magnitude, right? So formula is, so when you take it C or the resultant, whichever one, or resultant, will be equal to square root of the sides square, right? 33 square plus 44 square minus 2 times 33 times 44 times cos 150 degrees. So you plug that in the calculator. You can pause and do the calculation and check if you do it correctly. You should be getting around 74.4 Newton. So that's the magnitude of this side, 74.4 Newton. So that's about magnitude we have found, tick. Now the next one is direction. So for direction, I've told you before, sine rule will be handy. Now look at the opposite sides and opposite angles that I know of from the situation. Now this is 74.4 Newton. The angle is 150. So opposite angles I know here. Yes. And I will find this angle theta. That's the resultant, right? So I'll find this angle theta. So theta's opposite side is 44 Newton. So I'll be connecting 44 Newton theta, 74.4 and 150 degrees, right? So I start with the side. If you wish to have the formula for sine rule, it's A upon sine A equals B upon sine B. So we use this formula here. 74.4 upon sine 150 will be equal to 44. So that's opposite side, right? Opposite side to this angle theta, 44 upon sine theta. Into the cross multiplication. So you will have sine theta equals, I'm just doing it at one step, 44 times sine 150 upon 74.4. You have been following previous videos, you know how to reach this step. I'm skipping that math equation. So this gives you 0.29 approximately, and theta will be equal to sine inverse 0.29, which is again approximately 107 degrees. Sorry, uh, 17 degrees you will get. Alright, so this angle is 17 degrees. But see, the situation, we have found the resultant vector, the closed triangle method, all that is fine. But will it be acting here? No, it will be acting from the same point, right? For you to have the forces at equilibrium, so you need to switch the direction. So you measure from this point the total angle